we have already gone through the question. So if you are now going further, then you have solved it again right now, not at the midterm time, now in the quiz time, and make sure that parts A, B and C are fully solved by you before you go and look at the solution. So let us see. You have this graph, it is there in the book, right? You have this graph. The values of dn are here, the values of 1 by n is here. Plane stress condition, so this is already important. Delta is equal to dnj upon sigma naught, right? And we were given in the question that sigma naught should be taken as the yield stress. So first things first, in this part of the course, the EPFM part, GC, the critical stress, this is K1C squared upon E. It was the same as earlier also in one case. So if K1C is given, then just a square of this upon a square of this, and the value will be 12.08 kilojoule per square meter, right? Very simple calculation. Delta C, remember now the theory is there, the Wells theory and so on. So don't use any other equation. Delta C is 4 upon pi G upon sigma ys. This is G, this is yield strength, 4 upon pi. So very simple. 4 upon pi, G value you have just calculated, and sigma y is given to be 500 megapascal. So this comes out to be 0.031 millimeter, right? I mean 3.075 into 10 raised to minus 5 meter, but don't leave the answer here. This is a very bad sort of unit. Convert it to millimeters, then it is a reasonable size. So here and here, I mean, this equation you must know. This, I mean, if you had gone through the notes and if you had gone through the book, that with Wells theory, this is the value that you find CTOD in terms of energy release rate. Finally this for sigma naught is equal to sigma ys, sigma naught, right? So this is sigma naught by E. These curves are sigma naught by E. So it means it is sigma naught by sigma ys upon E, right? Sigma ys upon E. So sigma ys upon E 500 and E is 207 × 9. So this value comes out to be 0.0024. And because n is equal to 4, so 1 upon n is equal to 0.25, right? So from here, this curve is the 001 curve, this is the 002, this is the 004, this is 0024. So we will take the second curve roughly. We will take roughly the second curve 0.002 or 0.0024. So this is the curve, this is the curve, and 0.2, 0.3, right? So if it is roughly 0.25, roughly 0.25, so this is roughly exactly in the middle. You draw a vertical line here, cut the second curve, draw a horizontal line there. If this is 0.2 and this is 0.4, this is not exactly 0.3, right? So I have made it to be roughly 0.32. You can be slightly different, but you can't be less than, I mean, you can't be 0.25, you can't be 0.8. So roughly here, right? Roughly around 0.3, around 0.3. So I have taken dn to be 0.32, and that's it. Then the equation is already given. J is equal to delta sigma naught, which is sigma ys upon dn. So J is equal to 1 upon dn sigma naught delta. Dn we found out to be 0.32. Sigma naught is yield strength 500. Delta you found out there, right? So you write all the values. You will find that this is 48.05 kilojoule per square meter. 48.05 kilojoule per square meter. If you are using megajoule per square meter, this will be 0.048, right? But that will be the answer. So part A and part B of this question were very simple. Part C meant that this graph is there and the equation to solve is already on the graph and all the values are given. So this is not very good. Now the thing is that I write, when I write the quiz or the exam, I say show all the calculations, show all the assumptions, refer to the figures or the equations. So you can write that I'm using figure 3.18 from the book, right? This is figure 318 from the book. So write that I am using this equation. Many times many students are doing it correctly, but they do not tell me the source. So this is not right. This is a small minus half or a minus. Show me the source where you are solving it from. So if this is equation, this equation numbers are there, using equation number so and so from the book, using figure number so and so from the book. So if it is there, then it should be there, right? So this is it. All the questions of the midterm, all the questions of quiz 3, all the questions of quiz 4. This should be a good tutorial practice for you, and also the understanding of whatever mistakes you made. So we have to stop here. But usually our tradition that if we are in a class, we give you a small mental break. So I'll give you a mental break. This is the end of the course, right? The last time I am talking to you as if we are in a class. Now we will meet, either you come to my office to discuss something or we will meet in the exam. So this joke type of a thing is slightly higher level. Knowledge is knowing that tomato is a fruit. Now this is a debate in the English language, that tomato is a vegetable or tomato is a fruit. So many people argue botanically on the basis of botany, the science of biology which deals with plants and so on. So knowledge is knowing that a tomato is a fruit. Wisdom is not putting it in a fruit salad. Do you understand? That knowledge may tell you that tomato is a fruit, but when you are making a fruit salad, please don't put potato there. And now the highest level, knowledge, wisdom. Now philosophy, where you argue and think about deep things. Philosophy is wondering if the previous two things mean that ketchup is a smoothie. You understand a smoothie? You use fruits and yogurt and so on to make a smoothie. So if tomato is a fruit, this is a philosophical question. Is tomato ketchup a smoothie? Mental break is over. All the best for the final exam, inshallah. As I always remind you that the best preparation is that you revise the lectures. That is one thing. When you are revising the lectures, whatever solved examples are there, don't look at the solutions. Solve each example as a new problem and look at the solution only once you have completed the solutions, right? Next part, there is chapter 13 in the book, and there are questions in the relevant chapter of the Callister book. So from there, solve any extra problems, right? And if you are very, very adventurous, then you can go to one or two other books on fracture mechanics, which are available in the library, or you can go to the net and solve a few more. And again, from now until the exam time, if you have any doubts, any questions, you can come to my office. You can write me an email if you don't find me. We can meet in person. I can have a small Google Meet session with you. So if you have any doubts or any questions anywhere, do that. My only request or comment, I'm smiling as always, that you see, if you don't come to me to remove any doubts or other things, then you feel that you are very good in the subject. So then don't come to me after the final exam that please I need your help, right? Any help that I can provide to you is before the final exam. So if you have any doubts, any questions, meet me online, meet me in the office, remove your things, show me your solution, we'll discuss that. But once you come directly to the exam, it means you are fully prepared. So thanks a lot. It has been a pleasure spending this semester with you. Hopefully you have enjoyed the course to some extent. Of course, an elective course or a beginning postgraduate course is always slightly more difficult than a traditional routine undergraduate course, but that is why it is more interesting and more challenging. And this is sort of a small preparation for you to perform better in the field as engineers and so on, because when the level is slightly higher, maybe you don't need fracture mechanics exactly, but your mental level increases in solving these problems and analyzing the physics and the math of the problems and so on. So all the best for your future and the exam. Ma'as salama. See you inshallah.